All right, hey, my name is Jordan Miller, and if you haven't seen the first part of this video, the Science of Second Chances, I recommend that you go back and you check that out because that's going to give you a lot more context for what we're going to be talking about today. For those of you that have made it this far, thanks for making it this far. It's an honor to have you. And as promised, it is coding time, folks. All right, awesome. So as I mentioned, this is a companion piece. We're going to do some deep dive into the code. And how this video came to be is, as I made the last presentation, I tried to keep the code as simple as possible because I knew that I had a very mixed audience and I wasn't sure exactly how many even developers I was going to have in the audience, much less Clojure developers, which are few and far between. And so I made the presentation using the simplest code to explain I knew how. And so afterwards, I was talking about it with some fellow Clojurians, and they had offered some refactoring tips. And me being me, I had some extra time, so I started going back to start playing the sand and mess with my algorithms and see how I can improve and just learn to be the best coder I can be, and then also just improve my code that I'm going to put out there. And as I was doing that, I started to think about that quote from that Hal Abelson said in the SICP video. If you missed it, then here you go.
Science is a terrible name for this business. First of all, it's not a science. It might be engineering or it might be art.
So it might be engineering and it might be art. That quote really resonated with me. When you first learn how to program, it's so hard to understand just even like one way of doing things and how to do it. And much less appreciate just the multitude of stylistic choices, architectural decisions, all the things that go into being what I would consider a software engineer as opposed to maybe a developer. And that's just my personal views on it. And I'm at a very interesting point in my programming journey where I'm still considered a novice, especially compared to most Clojurians that have been programming for years and years and years. I'm a little bit special because I started with functional ideologies. But I can still remember what it was like to not know anything and just be completely lost. But on the other hand, now I'm getting to the point where I have started to appreciate and see the nuances of elegance and expression and all the things that people love about these functional languages. And then also the associated, there's pros, there's cons, common pitfalls it's really easy to fall into. And so part of what I'll be sharing today is some of the steps that I took when I went through transforming and refactoring my code to be more elegant and more expressive. And like I said, just be a better programmer. And I'll also discuss some of my thoughts about the trade-offs that an engineer may need to make when, aiming for the highest point of elegance you can possibly be, which is what we're all aiming for, right? So the target demographic for this video is people that do Clojure. Now, if you saw my video and you're just super fascinated in Clojure, that is awesome. You should totally get into it. I heavily recommend that you start with the book Clojure for the Brave and True by Daniel Higginbotham. I will link it in the description below. That is where all of us started. And I truly believe that it is a great place to start. So, like I said, besides that, this is meant to be a discussion. As I said, I'm a little bit more novice. I only have a couple years under my belt. So I want to hear your thoughts. I want to have a conversation about this. And to that end, I will put up my links, and if you want to connect, a way to talk, that'll be the next slide. So take a look at that. The repo that I'm doing this demonstration in will also be available on GitHub, so check that out. And all right, guys, let's dive into some code. All right, before we get started, I will put some disclaimers out there. So this is a one-off project, so I'm not going to be following every single best practice and every single thing to do with architectural patterns. It's meant to be discussion, exploration, a presentation, but just keep that in mind when you're looking at this code. So this is Clojure code, just Clojure, not Clojure script. Clojure script is also awesome, but the tooling, whew. So this is Clojure code. It's written in Emacs using Cider. And of course, because I use Emacs, if you don't, of course, I'm better than you. I'm totally just kidding. I actually use a lot of different IDEs based on the task that I'm doing. But yeah, that's what this is. I'll also use some cool Emacs shortcuts to explore some data. And in the description, I will try and show the name when I do describe key of any functions that I use. So me personally, I'm very data in, data out with the way that I like to program. And so as a result of that, my programming patterns rely heavily on the REPL. Like you've heard of test-driven development. This is that on steroids. This is REPL-driven development, which is awesome. I use a technique that I call def and test, and it involves evaluating variables into my REPL, and that effectively stores them in memory. And then I use those stored variables from my REPL to test and run my code, to test my functions. To that end, I left some comment blocks in there, which not best practice, but it's going to assist in this presentation here. And unless you're Rich Hickey, you shouldn't do that. But I did it here, so just letting you know. I'll probably make another video focused on the def test technique because it's really cool and not a lot of people know about it. But for now, when you see me doing def foo bar and then evaluating it, that's what I'm doing. So without further ado, I guess let's dive into the code like I keep promising. Coming at you live, straight from the code. All right, first thing we do is we import these libraries to help us parse the CSV. If you saw in the previous presentation, I couldn't get my hands on the data set, so what I did to just create these algorithms is I made a Google Sheets document with mock data, and then I downloaded it as a CSV. And this is a great library by Seancorefield. Thank you for all of your great libraries, Seancorefield. That helps us parse a CSV. Those values come in as strings, and so this is just a helper. This would probably go in a utils if this is a larger project, but because this is a one-off project, it's just here. So what all this code does, if we're just going to abstract it out, is it gets the parsing out of the way. Is there probably a more elegant way besides 4 maps? Yes. Did I solve for that here? Not yet. I promise we'll get to the fun stuff. So now we have all hired candidates here. We can assign the value of running CSV data maps on the data that we assigned here. And when I go into my data exploration, we can see some information about it. So we see that this is a list of hash maps. We can even go in, look at it like this, we can even go into each hash map. There is a way to go back up and out, but I, for the life of me, cannot remember what it is. So, oh, that's not it. So thank you, Emacs, for now. I'm just gonna close it using Q. And so all hired candidates goes into this function I wrote called valid candidates, which essentially scrubs the data. What we're doing is we're filtering by job position, and we're removing all of the maps that have nils in them. So I just do that using a thread last, remove filter, it scrubs the data. And from there, we can check valid candidates on all hired candidates and see what that is. So now we see the length of this list is a lot shorter. It's 15. And I bet if I really wanted to, I could go into each one of these things. I'm not going to. I can check and there's not going to be any nils in here. The data is all clean. So that was the first step as far as scrubbing the data. I also use this fun little ditty I've been getting into. Call it Let Fun because it's super fun. And if I get up the documentation for you here, we can see that it's a macro. And what it does, essentially, it's the same thing as casting an anonymous function to a variable in a let. It just kind of cuts out the middleman. I've been getting into it because it's really useful to build transducers, and that's what I've been kind of playing with lately. So yeah, just a little tip. Let Fun is pretty fun. Okie dokie, so using that def test technique, we are going to make a variable called valid hired candidates that we can then pass into these next functions we're going to talk about. I'm going to go to that, evaluate it in my REPL. I can go back, check it out. Valid hired candidates, 15, that's what we wanted. All right, cool. So this next function I wrote for the presentation. It was the first pass. And maybe it's not bad code. We'll go with mediocre. Why? Well, first thing is question marks are typically reserved for true, false. This returns data. It's bad, not good. Bad, bad, not good. How I did this isn't terrible. However, you can see that a couple of, there's a couple of repeated code here. Now, it certainly is readable, which is nice, but it's not the best code we could write. It was suggested that, hey, yeah, that whole thing can kind of be replaced with a reduce. So here we go, replacing it with a reduce. When I say we, I mean I gave it a better name. So separate genpop. I'm sure if you guys are programmers, you know that naming things is super duper hard. So separate genpop. And it takes those valid hire candidates and it reduces based on whether they have a criminal history or not. You should check out the reduce function if you aren't familiar with it. This is the data set that's getting passed into the reduce, and then it goes through and it updates each one of these lists based on whether the person has a criminal history. The collection we're passing in is valid hire candidates. And when we go down here and do separate genpop on valid hire candidates, oh, we get this. Oh, super readable. Let's look at this. So we have an array here, and then you see the hash maps that I had passed into the collection. I had passed into reduce, and we see these nice lists built up here. See that this list is 8 hash maps long. Each hash map is a person. If you go in, this is second chance candidates, and so criminal history is going to be 1 for each one of these candidates. On the other side, no criminal history is going to be the opposite. They're all going to read 0. All right, cool. This is still left from my presentation when I was demonstrating the data that was coming out of there. All right, that was the reduce. I'm going to pause and I'll see you in the next section. That's where it gets really fun. All right, here we are at the next section, and this is where I'm going to start to get into some of those decisions I was talking about as far as elegance and expressiveness and architectural design. We start off by, I just wrote a helper. Like I said, typically this would go in something like utils, but it's right here. I looked for average or mean for any library for Clojure and couldn't find it, which was very surprising, but okay, all right, it's fine. Write it myself. And by write it myself, I mean search on Stack Overflow for it. I turned it into a float because that's what I wanted to work with here. And then I also made this function called length of employment that simply just iterates over a candidate pool, and it pulls the length of employment for each one. So if we did, caps, length of employment on, for example, valid hired candidates, we just get a list of numbers. And then we can call average on that. Cool, and we get the average of those numbers, which is why those helpers were written. So compare LOE alpha is the first pass. This is the code that was in the presentation. And I didn't call it bad code this time because no code that you write with true intention is bad, but it's pretty mediocre code, so we'll call it medio-code. I'll probably trademark that. So average LOE does exactly what I did up there. And then the way I had created this by design originally when I was creating it for the presentation is I designed each function to be able to take mostly the same candidate pool of valid hired candidates. I did this for ease of explanation. Also, I think in a bigger project, there is something to be said for all the logic being abstracted out into one function. So a lot of the pitfalls that object-oriented programming can fall into is issues when you're passing around immutable state everywhere. And I think the same thing can be said if the input of each function relies on the output of the function before it. Now, you might say to me, well, Jordan, that's the whole point of functional programming. And yeah, I know, but this is just a discussion. It's something to talk about, because if you do it that way, then what can happen is you can fall into the same sort of bugs, where if there is an error in one function up here, and you're passing the output of this function to this guy, you have a function up here that has a bug, and then the whole rest of your data is tainted, and that's a bummer. So when I originally made this, for two reasons. One, to explain to people. It's easier that everything takes the same input. And two, because it's a small enough project, I didn't think there was a need to have each function rely on the output of the one before. But because we're improving the code and refactoring, that's going to be one of the things we will address. So compare LOE takes these valid hire candidates. And for criminal histories, here's a bug. See, here's a bug right here. We actually want to do separate gen pop on valid hire candidates. Cool, so we have what we had before. And then attach that to criminal histories. And I'm going to go down here and just evaluate this to save that change I made. So criminal histories, this is doing the work that we did in the previous steps. Now, one of the problems with making each function do all the logic internally is you're at risk for overloading logic in the function. So that's kind of what's happening here. These next two steps gets the average length of employment, and the data that it passes in is the list of no criminal history and the list of second chance candidates. Now what we're returning here, like I said, I'm a data in, data out girl, and we're passing this data in, and we're outputting a hash map. Gotta love those hash maps. And it has all of these things that we want to know. So if we do this, we can see it returns this hash map where we have the average length of employment for all the candidates. We have the second length of employment for second chance candidates. It then does a little bit of math, and it returns, or maybe not math, yeah, math. It returns to us the longest tenure on average. Now, like I said, this is okay, but it's pretty mediocre. And we're going to take a few steps of refactoring, and we're going to show why. We're going to show, oh God, I keep saying we. I mean I'm going to show the different choices that we can make here. So, see you on the next function. All right. We got second pass at trying to make this function the best function that it can be. So, decided to use my handy little let fun, and since the length of employment function isn't actually used anywhere else, we can just let it be inside the scope of compare length of employment. It makes things a bit easier. Like I said, a helper like average, I would typically put into a util somewhere else because it's just such a general helper. You're probably going to use it more than once. That's where that goes. That's where that belongs. The other things I did is somebody once told me that if you use caps in your variable names like this, everybody will hate you. So don't do it. So change it all to lowercase because that's what I was told once. I would love to hear what you guys think about using caps in variable names. I guess comment or message me. I'd love to hear your opinion on that. So, we have that same error copied over, and we're going to do separated gen pop. We're going to do the same thing where this function is still overloaded with trying to do the data transformation since we're trying to pass valid hire candidates into it. We're going to deal with that on a next step. The main change we did in this one was using comp as opposed to repeating ourselves with this thread last. So I think the difference between comp and thread last, it kind of reminds me of the good old partial versus anonymous function debate. A lot of functional programming circle, like truly traditional functional programming, would say to use partial and comp, function combinators. And this is good if you're trying to be, if you have a typed system, if you have Haskell, if you have other things helping you out to debug. But I think there is an argument to be made that sometimes using an anonymous function or using a thread last can be the better way to go. It just really depends on the code that you're writing. I wanted to practice using comp, and so that was the next step. We do see that it reduces our line count, I think by 2 or 3. And as you can see, it is more elegant and expressive. Things like partial and comp can be a lot harder to debug, but if you know how to use them, they can be pretty sweet. You feel pretty slick whipping out a partial and comp. That's mostly the biggest change we made in the second iteration. We're still returning this data set. If we do compare LOE second Oh, horrible, horrible name. I am just horrible at naming things. I'd like to get better. Did any of y'all get better at naming things as you programmed more? Uh-oh. Oh, well, maybe we need to make compare LOE a function first. Huh? Ah, there we go. All right. And so we can see we have the same values. Cool beans. Let's try and improve this just a little bit more. See you on the next step. Haha, just kidding. One more thing to say about this second iteration here. One of the benefits of using comp is, like I mentioned earlier, I've been having a lot of fun trying to learn and master transducers. And replacing your thread last with comp is a way to get in the pattern of thinking like that. That was actually recommended to me by a friend of mine, so it's good advice. It is worth mentioning when we're talking about comp. So, all right, coming at you with the third iteration here. We've got one more to go. So this one, like I mentioned, we want to maybe look at what it's like to pass it the result of separate gen pop on valid hired candidates, as opposed to just passing in hired candidates. So here, we're doing that. I'm destructuring based on the keys, so I can just use them directly. We're still keeping this let fun since length of employment is really only used in here. I'm going to comp average and length of employment and attach it to av LOE because I am just fabulous at naming things, as discussed. Although, wait a minute. If we want to get to average LOE, we still have to put the two data pools back together again. The alternative is, I suppose, you could pass in something like, valid hired candidates up here, and then as a second parameter, pass in the value of separate gen pop on valid hired candidates. But I didn't do that. That's just another way we could have gone with this. All right, so even though we thought we were going to cut down on overloading logic, we still have to do some steps for that. So there, I'm just taking the two lists and combining them and getting the average of those. We still have our lovely comp, making these short and sweet. This is starting to look better, but there's still something not so great. Any y'all know what it is? I bet some of y'all, it's just been screaming in your head since the beginning. Well, if your guess was, what is this doing in this data set, you are 100% correct. It is not a good idea to separate it's not a good idea to have the human readable interpretation of the data and the raw data in the same data set, typically. That's what we need render functions for. That's how we do things in the right way. So that will be the next and final step. All right, folks, we're at our last iteration, finally. What this does is this separates the data from the render. We really only want to return data and keep the data to the data, and then keep the human readable interpretation in a render function like this. So here, compare fourth LOE only returns these three values. To grasp what those values mean, then we go down here to the render compare LOE, where it takes the three keys and it actually decides what that means. If we evaluate this, we get a string that a human can read. It's groovy. And that's all there is to it. Some other things to think about. So I've also seen in a code base where everything, this is more true in ClojureScript, I would say, where you do something and then it's render something. Do something, render something, and you just end up with all these render functions. That's no good either. If you're naming, in this case, it worked because we had one thing and then we're rendering the one thing. But something to be careful with in ClojureScript is just being repetitive with naming things render. So the things we did here, let's take a look. We started with this mediocre code. Everything was, the function was overloaded. There was a lot of repetition. Now it was pretty readable. You can look at this and you know what it's doing. However, we're able to save some lines and be a little bit more expressive and help our thinking patterns become better functional programmers by using tools like comp and partial. Are they the best fit every time? Not necessarily. However, it's really good idea to practice using them, especially if you're trying to just improve your skills. We go down here and we're able to change the data that we're passing in, and that's able to make things a little bit more elegant. Like I said, things could be a little shorter if we were to pass 2 parameters, but this is fine for now. And then the last step is separating out this data with the human interpretation of the data, because that's how you want to abstract things out. So I've covered a few things here. I want to hear your thoughts. Like I said, I'm a little bit more novice. I'm just starting to understand the intricacies and nuances of using these different techniques. Go ahead and comment below if you have anything to say about this. Please be nice. And I look forward to hearing from you folks in the comments and on the Clojure Slack. You can usually find me by my moniker, Lambda, which is supposed to be lambda, like lambda calculus, and duh, like duh. I know, pretty funny. I will see you next time. Thanks for tuning in.